Hi guys, this is Saurav here and welcome to another session for the Aspire series meant for JEE Advanced 2019. You know that we are conducting a number of such sessions for physics, chemistry and mathematics, and this is to ensure that your sailing to the JEE Advanced 2019, that is to be held in the month of May, is as smooth as possible. In chemistry, up till now we have finished liquid solutions in two parts, liquid solution 1 and liquid solution 2, as well as electrochemistry, which was electrochemical cells, that was covered in electrochemistry 1. This module is electrochemistry 2, which primarily focuses on electrolysis part, that is electrolytic cells and the processes which will be taking within it. So without much ado, let's start with today's session with the first problem, which is about a very common compound. And common compound से ये आप हमेशा याद रखिए, अगर common बोला जाता है और electrolysis की बात आ रही है, then it must be sodium chloride. Okay, so our first compound and the first question for the day is about sodium chloride. Let's read the question first. So one of the major concentration areas in the topic of electrochemistry is identification of products. And let's look at the question. Which of the following statement is or are correct about the electrolysis of aqueous NaCl? Now, aqueous NaCl can be electrolyzed using platinum electrodes. Aqueous NaCl can be taken in a normal dilution, or it can be taken in a highly diluted form. There is also one another way it has been electrolyzed, with a reactive electrode. Now, whenever electrolysis takes place, you have to remember that the outcome depends on four things, four factors. The first factor is the potential. You can see these potentials. The first factor is potential. This is known as the reduction potential or oxidation potential. And how do you identify that where reduction takes place and where oxidation takes place? Anode is the electrode where oxidation will occur. Cathode is the electrode where reduction will occur. Now, how do you judge on the basis of these? Now, suppose I have to oxidize something. There are two competing reactions which are trying to undergo oxidation. The one which has the most negative delta G value or the least positive delta G value will be more favorable. आपको याद होगा, we had discussed earlier that delta G is equal to minus NFE. So if we look at this scenario, then we have to compare, like all these values are are negative. So we have to consider the least positive delta G value. This is the first factor, that is discharge potential. Second is dilution. If it is more diluted or less diluted, the outcome changes. Third is nature of electrode. If electrodes can be platinum, like non-reactive, or reactive electrodes like mercury, which can react with the products which are produced. Okay, and the fourth factor is over potential. Over potential is an important term which we will encounter in this question, and I'll explain you what over potential is. Now, in this question, I have to analyze these four statements, and these four statements would be either all of them can be correct or kuch correct ho sakte. So it's a multi-option correct question. So let's try to evaluate what is the answer to this question. So the first statement is, during the electrolysis of NaCl, chlorine is liberated at the anode. Let's look at the statement and whether it is correct or not. So what I do is I write all the potentials and then I try to identify which has got the most negative delta G. But since values are given in terms of negative, so let's try to write the reaction first. So हम reaction पहले लिख लेते हैं and then try, because while I write the reaction, आपको reaction भी याद हो जाना चाहिए. Okay, so the first reaction is of if cation is there, if cation is present, it will move to cathode to undergo reduction. So I'll write the cathodic reaction. At cathode, what will happen? There are two competing reactions. Na plus is trying to get converted into Na by taking up an electron, and H2O is trying to convert into hydrogen. Now, generally, in most of the books it's written that H plus changes to H2O. That is not a very correct way of representing this. Please don't do that, because you will not be able to evaluate a number of other changes. Why? I'll tell you. H2O changes to H2 and the reaction takes place like this. Okay, for this E0 value is given as Na plus to Na plus to Na minus 2.71. For this, E0 value is given as minus 0.83. All of these are terms of volts. Let's write so these are the two competing reactions at cathode. There are two competing reactions for anode as well. First reaction is H2O, which is trying to convert into O2. Okay, H2O which is trying to convert into O2. This is the reaction. This is how the reaction takes place. H2O, O2, 4H plus 4 electron. This is what the reaction is. Try to remember these two reactions. For this H2O conversion into O2, E0 value is taken as minus 1.23. And there's another reaction, Cl minus converting into Cl2, in which it is also giving out an electron. Let's say I write it as half Cl2. E0 value is given as minus 1.36. Now, if I look at the feasible reactions at the cathode, how do I identify? Sare negative mein hai, so I'll take the least positive delta G, because delta G is related, delta G is equal to minus NFE. What I'll do is, I will try to take the least positive delta G. Least positive delta G or most negative. Negative तो मिलने का नहीं हमें delta G, क्योंकि E value is negative. I'll not get the value of delta G is negative. So I'll look for the least positive. So least positive will be this or this. बताइए, this one or this one? It will be this one. Obviously this one. This will not be least positive. Correct? Between these two, which will be least positive? The first one rather than the second one. However, even though this is less positive, this reaction is not favorable. This reaction is favorable because of the fourth point that I told you, which is known as overpotential. A number of times we find out that a reaction is thermodynamically favorable. Thermodynamic favorability means it will go until the end. For example, rusting. Rusting will go until the end. It starts, K value is very, very high. However, rusting is an extremely slow process. Extremely slow process. Similarly, H2O conversion into O2 is thermodynamically highly favorable. अब देख सकते हैं thermodynamically favorable है, but the reaction is so damn slow that to make the reaction run at a appreciable rate, you have to increase the potential. The extra potential that you need to add will supersede this value, and that is known as overpotential. So H2O conversion into O2 will always be associated with a certain degree of overpotential, and it is slightly more than this value, and which makes the total value slightly more than this, more negative. And because of that, the second reaction turns out to be more favorable. So remember, when you are electrolyzing aqueous NaCl, hydrogen very well can be identified to be liberated at the cathode. However, chlorine would be the one liberated at anode because of the associated overpotential of oxygen. Okay, so because of this, during the electrolysis of NaCl aqueous, chlorine is liberated at the anode. So the first statement is correct. Okay, After the electrolysis of NaCl, the solution turns alkaline. Why it turns alkaline? Now, chlorine is liberated. What was the other reaction? The other reaction was conversion of H2O into H plus. Why did I ask you to remember this reaction? Is because of this region. अब देखिए, sorry, H2 plus 2OH minus. Now, if you don't remember this reaction, it will be impossible for you to identify how OH minus gets produced. So you can see that with the production of H2O, with the production of H2, with the production of hydrogen, you are also getting OH minus. With the production of hydrogen, you are also getting OH minus. And because OH minus is produced, the reaction will lead to an alkaline solution towards the end. Initially solution neutral रहता, धीरे धीरे solution alkaline होता जाता है, मतलब pH will keep on increasing from 7 and onwards. So after the electrolysis of NaCl, the solution turns alkaline, which is a correct statement. During electrolysis of very dilute, what is the meaning of very dilute solution? A very dilute solution will find it very difficult to have a substantial amount of chloride ion in the medium, a substantial amount of sodium ion and substantial amount of chloride ion in the medium. Since substantial amount of chloride ion and sodium ion is not present in the medium, the reaction eventually takes up the reaction takes up those components which are present in greater amount, in which the collision frequency is higher, in which the reaction favorability is higher. So reaction is dependent on the amount of substance, and since their amount is so damn low, the reaction goes in favor of the other competing reaction. Sodium competes with hydrogen, so hydrogen is liberated, and chloride competes with oxygen. Since chloride amount is so damn low, overpotential plays a very small role over here, and oxygen is eventually liberated at anode. Okay, oxygen is liberated at anode. The last statement, during the electrolysis of NaCl aqueous using mercury electrode is a reactive electrode. Of the 4 points I've illustrated discharge potential, over potential, concentration, and the last point was reactive electrodes. Reactive electrode is one which can react with the component which is produced. Now, mercury electrode will induce formation of amalgam. Since sodium amalgam is produced, the reaction eventually gets dragged in the forward direction, and because it moves in the forward direction, the production of, you can say that the reduction of Na plus becomes more favorable. That reaction was not favorable, but since the products start getting removed using combination with mercury, so sodium is reduced, Na plus is reduced rather than hydrogen. So during the electrolysis of NaCl using mercury electrode, sodium amalgam is formed at the cathode. So our correct answer for this question will be A, B, C, D. Clear? Let's move on to the next question, which is on the similar lines. So the next question is very similar. In electrolysis of 1 molar nickel sulfate NiSO4, or if electrolysis of 1 molar NiSO4 is carried with inert electrodes, platinum ले लिया, so no reactive electrode, at pH 7, gas is taken at 1 bar. The product of electrolysis at cathode and anode initially are. Product of electrolysis at cathode and anode. If you do not remember, let's say 2 values are given. Nickel reduction potential is given, hydrogen's liberation, like H2O's reduction potential is given. So nickel Ni2 plus competes with H2O liberation. So Ni2 plus, sorry, Ni2 plus competes with H2O. Okay, it competes with H2O. For this, the value is 0.25 minus 0.25. For this, the value is minus 0.83. Now tell me guys, which will give a less positive value of delta G, less positive value of delta G? This one. So what should be liberated at the cathode? What should be liberated at the cathode? Nickel. Nickel should be liberated at the cathode. But what would happen at the anode? I know for a fact that H2O conversion into O2, this E naught value is minus 1.23. ये हमने पिछले क्वेश्चन में किया. Okay, the previous question we did this. But there is another anion, sulfate. What happens to sulfate? If sulfate is taken, sulfate converts to S2O8 2 minus, and for that E naught value is 2.01 volts. 2.01 volts. It's a very large value. Okay, I'm sorry, minus 2.01 volts. E naught is minus 2.01 volts. It's a very large value. So even if you take into consideration the overpotential of H2O converting into O2, that even taken into consideration will give a smaller value as compared to the discharge potential of sulfate to S2O8 2 minus. So in this reaction, this value is so damn high that even overpotential plays a very small role. Overpotential is insignificant because of the very large value of E naught over here, and because of that S2O8 2 minus is not going to be liberated at the anode. What will be liberated at anode is oxygen. Okay, so if or whenever you see a reaction where sulfate is present and O2 is present, then O2 will be liberated. O2 and chloride is present, O2 will not be liberated, chloride will be liberated if the concentration of chloride is appreciable. If the concentration of chloride is very low, then oxygen will be liberated. Okay, let's move on to the next question. So guys, let's look at this problem. The problem is about molar conductivity. Molar conductivity of a solution of weak acid is 10 times smaller than the molar conductivity of another weak acid, HY. And their respective concentrations are also given. If lambda naught x minus is equal to lambda naught y minus, then the difference in their pKa values is to be calculated. This question came in JEE Advanced 2015, and that's a very easy question. The question was asked as an integer type question, and the question doesn't take too much of time to solve as well, and it's a very straightforward simple question. One thing that you have to remember, that it is molar conductivity, and lambda naught represents the molar conductivity at infinite dilution. That means when a large amount of water is present, that means there is absolutely no attractive interaction between the cation and anion, and each ion is behaving independently. So how do we solve this question? To solve this question, what I will first do is I'll write this relation. Lambda naught x minus is nearly equal to lambda naught y minus. If I add lambda naught h plus on both sides, since H plus ion behaves independently, what I would obtain is lambda naught hx over here, which is nearly equal to lambda naught hy. Okay, I will obtain lambda naught hx, which is equal to lambda naught hy. Now let's move on to something else. I will take this relation that lambda at any concentration by lambda naught hx is equal to alpha 1, let's say that is for hx, and lambda for hy at a given concentration by lambda naught for hy is equal to lambda 2. Okay, fine. Now I can write lambda hx is equal to lambda naught hx times alpha 1, lambda hy is equal to lambda naught hy times alpha 2. Now there is another relation which is also given. The molar conductivity of a solution of weak acid is 10 times smaller than the molar conductivity of hy. So hx is 10 times smaller than hy. hx is 10 times smaller than hy. So can I write this over here, that if I take lambda hy can be written as 10 times lambda hx, which is equal to lambda naught hy times alpha 2, which can further be written as lambda hx can be written as lambda naught hx times alpha 1, which is lambda naught hy times alpha 2. और यहाँ तो हमने प्रूव कर दिया है इसको, सो ये कैंसिल हो गया. आपके पास रिलेशन क्या बना, 10 alpha 1 is equal to alpha 2. 10 alpha 1 is equal to alpha 2. Let's keep that in bank and work on it like this. Hx will dissociate to form H plus plus X minus. Any weak acid will dissociate like this. So if it is given of a certain concentration C, so I will write it as C 0 and 0, C 1 minus alpha, C alpha and C alpha. आराम से लिख दे सकते हैं. Okay. Now K would be written as, K for Hx will be written as, K for Hx would be written as C alpha square by 1 minus alpha. C alpha square by 1 minus alpha, but alpha is very small as compared to 1. So can I write this as C1? Let's say the concentration value is given which is different. So C1 alpha 1 square. So similarly K for Hy can be written as C2 alpha 2 square. Okay, दोनों को divide कर देते हैं. Let's divide both of them. So KHX by KHY will be written as equal to C1 alpha 1 square by C2 alpha 2 square, C1 alpha 1 square by C2 alpha 2 square. C1 value is 0.01. 0.01. This value is 0.1. Alpha 1 0.1 times alpha 2 is equal to 10 times alpha 1. So alpha 1 square by 100 alpha square, this gets cancelled out. Okay, so यहाँ पे 10 मिल जाता है हमें. Fine. So this becomes equal to 10 raised to minus 3. KHX by KHY, KHX by KHY becomes equal to 10 raised to minus 3. If I take log on both sides, what will I obtain? Log KHX by log KHX by KHY is equal to minus 3 log 10 or log Ka for Hx minus log Ka for Hy is equal to minus 3. -1 से मल्टीप्लाई कर दीजिए. सो -1 से अगर हमने मल्टीप्लाई कर दिया, सो दिस विल बिकम सॉरी will be equal to 3. This will become equal to pKa for Hx minus pKa for Hy, which will turn out to be equal to 3. So our answer for this question is equal to 3. Very simple, very straightforward question, where absolutely no hassles at all. Okay, so let's move on to the next question. So before we move on to the next question, I have a small message for you guys that Vedantu doubt solving app is one of the best apps on the Play Store, where you can ask your doubts, you can study, you can like refer to a lot of study material, all the videos, all the content is there, and so it will be a healthy learning experience on this platform after the sessions are over, after the YouTube sessions are over. And if you still want to like replay everything on your mobile phones, on your tablet, please do go on to Play Store, download this and have a wholesome learning experience. So our next question is this. This question is very interesting. Let's read the question. A 2 liter buffer solution of 0.2 molar NaH2PO4 and 0.3 molar Na2HPO4 is prepared. The solution is divided in half between 2 compartments, each containing 1 liter of the buffer of an electrolysis cell, and it is electrolyzed using platinum electrodes. Platinum electrodes are inert electrodes. Assume that the only reaction is electrolysis of water, and electrolysis is carried out for 200 minutes with a constant current of 0.965 amperes. What is the pH at the cathode? Now, if you look at NaH2PO4 and Na2HPO4, they look like a salt buffer. A salt buffer is one in which the anion, the salt, this is a conjugate base of this particular anion. It is obtained from a polyprotic acid. So I'll not go into the detail of that, but this is a buffer solution. This is the buffer solution. How do we calculate this? The question can be solved by breaking the whole part, the whole wording of it into 4 small parts. These 4 small parts are, the first part is identifying how much charge is flowing through the solution. Next, what is the reaction which will be happening at cathode? Next, what would be the outcome of that reaction in context to this buffer solution? And then using Henderson's equation. So 4 parts. So let's start with this. How do we do this? So first we calculate charge. So first work is to calculate the charge. So how much charge is flowing? So to calculate the charge which is flowing, I will try to calculate the charge in terms of Faradays. The reason why I do it in terms of Faradays, because I know that for one equivalent of a substance to be liberated at any particular electrode, 1 mole of electrons or 1 Faraday of charge is required. So let's look at how much charge is flowing. So Q is equal to current, which is 0.965, times time, which is 200 times 60. This is the charge which is flowing. This is the total charge, coulombs. Number of Faradays, will be 0.965. Don't calculate over here because you can see that 0.965 is there, so it will get cancelled out. 200 times 60 by 96500. Put 1000 over here. This goes away. This goes away. we have 12 by 100, so this turns out to be 0.12 Faraday. This turns out to be 0.12 Faraday. Now what is this one? First part is done. Next part is what is the reaction that will take place. Now in a cathode I can very simply write that this reaction will occur. H plus will change to H2. Now for utilizing 2 moles of H plus, 2 moles of electrons is required. Can I say that? For utilizing 2 moles of H plus, 2 moles of electrons is required. So that means for every mole of H plus, 1 Faraday charge is required. 2 moles of electrons account for 2 Faraday. 1 mole of H plus will account for 1 Faraday. So 1 mole of H plus requires 1 Faraday. So I have provided 0.12 Faraday. So how much reaction will take place? 0.12 mole of H plus will be utilized. But if H plus is utilized, what will be left in excess? If H plus is utilized, what will be left in excess? Please tell me what will be left in excess. OH minus, yes, very good. OH minus will be left in excess. And how much OH minus will be left in excess? जितना H plus utilize कर लिया उतना ही OH minus excess रहेगा. 0.12 moles. That finishes the second part of the question. Let's move on to the third part. How is it relevant for the buffer solution? So our buffer solution is H2PO4 minus, which is gonna change to HPO4 2 minus. Now if this reacts with a base OH minus, it will produce water. As simple as that. Okay, this is given as 0.3, this is given as 0.3 initially. Now if you add 0.12, this will get completely consumed. ये completely consume हो जाएगा. What will happen? This will also react, and how much of this will be left out? 0.18. And how much of this will be formed? 0.12 plus 0.3, that is 0.42. So 0.42 moles, 0.18 moles. That is our penultimate part of the question. The last part of the question is applying Henderson's equation, and you all know that Henderson's equation looks like this. pKa, so pH, which is equal to pKa plus log of salt by acid. What is behaving as an acid? H2PO4 minus. What is behaving as the salt? HPO4 2 minus. So I will write pK value is 7.2 plus log of 0.42 by 0.18. This will be slightly more than 2, so log 2 is 2.3010, so 7.5 should be the answer if it would have been 0.36, but since it is just 0.06 more than that, so there will be not too much of a change. It will not reach 7.6. It will be somewhere about 7.56 or 57, which is almost about this value. Okay, almost about this value. 7.55, 7.56, 7.57, something around this. So this should be the pH of the solution. Okay, very simple question, very straightforward, very logical, very conceptual, very fun to question. So guys, let's look at this question. This question is an extension of the previous one. Over here we have to calculate the pH at the anode, and how do we do that? To calculate the pH at the anode, we would be considering whatever we had done in the previous scenario, and in the previous scenario what we had considered was that the charge which is flowing through the solution is 0.12 Faraday. Now next I need to know what is the reaction which is occurring. What is the reaction? The reaction is this: OH minus, 4OH minus changes to O2 plus 2H2O plus 4 electron. So can we say that for 4 moles of OH minus is being utilized by using 4 moles of electrons, or 4 moles of OH minus is giving out 4 moles of electrons. So 0.12 Faraday for each mole, 1 Faraday is required. So 0.12 Faraday will discharge 0.12 moles of OH minus. Now if OH minus is removed, what will be present in the medium? What would be present in the medium? 0.12 moles of H plus will be excess. 0.12 moles of H plus will be excess. Let's look at the reaction. The reaction is very simple, the way we did earlier. Now HPO4 2 minus will accept a proton to form H2PO4 minus. Okay, so this was 0.3, 0.12, this was 0.3 initially, this will become 0, this will become 0.18, and this will become 0.42. As simple as that. Now apply Henderson's equation. So pH will be equal to pKa plus log of salt by acid. What is the pK value? 7.2. Salt concentration is, salt was HPO4 2 minus, it is decreasing and acid is getting formed because the salt is reacting with H plus. So ये कितना हो जाएगा? 0.18, 0.42. So whatever answer that we had gotten over there by adding log of something, यहाँ पे मुझे उसका subtract कर देना होगा. So 0.42 by 0.18 का log जो लिया था हमने, यहाँ पे उसका inverse ले, that means we have to subtract this. So this answer, earlier the answer was 7.56. Now the answer would be 14 minus 7.56. So this will be some 7.2 से कम रहेगा. 7.2 minus whatever was taken over there. So 14 minus 7.56 will be our answer. So the answer should be 4 and 6.44. Answer should be 6.44. Why have done 14 minus? Because that is the shortcut. See, the solution has to be electrically neutral. The solution will be electrically neutral. The pH of the solution will be electrically neutral. The solution in totality will turn out to be neutral. If the same extent of reaction is taking place in the cathode and the anode, the pH overall of the solution, the extent to which it will increase in one, that is the same extent to which it will decrease in one. So rather than doing this elaborate calculation, if I know that it is increasing by certain value X, I should reduce it by certain value, the same value in the other part of the electrolytic cell. Okay, so this is the long and short of it. It's a very beautiful question. You should try to resolve this question if you do get time, and this takes in so many concepts. Let's move on to the next question. Okay, so the next question is this. The next question talks about this fact that an aqueous solution of X is slowly added to an aqueous solution of Y as shown. What is the variation of conductivity? Variation of conductivity के ऊपर बहुत बार question दिया गया है JEE में, and it has become a regular feature these days. How do we evaluate this? always remember, if ions are utilized, then conductivity decreases. If same number of ions are produced, then conductivity almost remains the same. If faster moving ions are utilized and slower moving ions are produced, that means H plus is utilized or OH minus is utilized, then the conductivity decreases. Okay, so how do we solve the question? The first question is that we take this nitrogen triethylamine and we add it to acetic acid. Acetic acid is a weak acid. If I add triethylamine to it, what will happen? It will promote the ionization of acetic acid because it will slowly start removing the protons. If it starts removing the proton, it promotes ionization, it will increase the conductivity until neutralization takes place. The moment neutralization occurs, after that point, if you add any extra amount of base, nothing will happen because this base is not going to give out OH minus ion. This base is that kind of a base which will take up a proton. But if proton is not available in the medium, if you add an extra of it, it is not going to change the pH of the solution. So the answer to this would be conductivity increases and then does not change. So P's answer should be okay. So P's answer should be 3. Okay, P's answer should be 3. Next, Ki and AgNO3. Ki and AgNO3. Very simple. You have Ag plus NO3 minus, in which you are adding Ki, which forms AgI, okay, and produces K plus and NO3 minus in the medium. So you get almost the same number of ions present in the medium. It is just compensating it. NO3 minus is still present in the medium. Whatever Ag plus is lost, that amount of K plus is present in the medium. So as long as Ag is not completely precipitated, the conductivity will remain constant. Because this is just compensatory effect. We are just compensating, and the mobility of these ions are almost equal. So we are just compensating, the conductivity will remain the same. However, after this complete precipitation occurs, if you add some extra amount of a strong electrolyte, that is Ki, it will dissociate to a greater extent and it will increase the conductivity. So conductivity does not change much and then increases. So it should be 4. Acetic acid and KOH. Very beautiful question, because KOH contains OH minus. OH minus is a fast moving ion. The moment you add acetic acid, you are slowly consuming OH minus and combining it with H plus to form water. Okay, so OH minus, which is a fast moving ion, is now been trapped by H plus and it is converted into a slow moving weak electrolyte. So that means you are slowly decreasing the conductivity. And the moment complete neutralization takes place, beyond that, if you add acetic acid, what will happen? If you add acetic acid, you will expect that the conductivity should increase because acetic acid will dissociate, but in the solution you will have CH3COO minus K plus. And what is this? Salt of weak acid and a strong base. It will act as a conjugate base and will act as a common ion and will not promote the ionization of newly added acetic acid. So newly added acetic acid is not gonna make any difference. So the conductivity decreases and then does not change. Answer for this will be 2. Okay, is this understood? OH minus, a strong highly mobile ion, is being replaced and trapped into a weak electrolyte, and then you add extra acetic acid beyond the point of neutralization, expecting the conductivity to increase, but it will not, because there is a strong conjugate base, or there's a huge amount of conjugate base which is present, which will cause common ion effect and will not promote the ionization of acetic acid. Okay. The last one is NaOH Hi. Hi, I've again told you, H plus is a fast moving ion. You are adding OH minus to trap it. So what will happen? Conductivity will decrease. Conductivity will decrease. Now, beyond the point of complete neutralization, if you add extra NaOH, what will happen? Now you are adding fast moving OH minus ions in the medium, and so the conductivity will increase. So it will decrease and then increase. So conductivity decreases and then increases. Answer for this should be 1. So I have explained you 4 conductivity variation examples. You can plot a graph for this as well to validate your answer or to learn it in a different way as well. So this is like the end of today's session, but as like every session, I would want to end the session with a beautiful quote. And the quote is this: many a times we put a lot of efforts, and these efforts do not bring us all the desired results, and so we start doubting ourselves that whether our efforts were good, whether our efforts were bad, whether our efforts were as good as somebody else's effort, am I as good as somebody else? So we build in a lot of self-doubt, and that self-doubt usually starts piling up, and वो regret में बदल जाता है कि भाई हमसे ये नहीं हुआ, हमसे वो नहीं हुआ, I was not able to do this, I was not able to do this, and your dreams start dying, your ambitions, your passion starts dying. So it's always good to remember that doubts kill more dreams than failures. If you fail, you'll pick yourself up. But if you start doubting yourself, if you start thinking that I am not confident enough, I am not good at this, self-doubt, अगर आपको किसी ने 10 बार बोला कि भाई you are not good, then you'll start believing it. But self-doubt is the biggest enemy. So if you want to succeed, you need to have faith on yourself, on your abilities, all the hard work that you're putting. If that's a honest hard work, it will always pay off. Sooner or later it will pay off. Okay, do not doubt yourself and always believe in yourself. That's my message for today. We'll meet in the next session with an exciting topic, that is coordination chemistry. Until then, I hope you solve as many questions as possible on this topic and post any doubts that you have on the doubt solving app. In case you want to reach out to me, I can be reached out at saurav.goswami@vedantu.com. So please drop a line if in case you want to connect. So that's all for today, guys. I hope we meet very soon, and all the very best. Bye-bye.